It's about understanding how the world around them works.
When and how do you introduce machine learning concepts?
Machine learning isn't this futuristic technology. It's here, it's now, we're using it.
And a lot of kids often ask, like, how does that work? What is going on?
You should let young people play and tinker. Welcome to Hello World, a podcast for educators interested in computing and digital making. I'm Carrie Anne, a computing educator, content creator, and it doesn't matter how many jokes you train me with, I'm still not very funny.
And I'm James Robinson, a computing educator. I work on projects promoting effective pedagogy within our subject. If you want to support our show, then subscribe wherever you get your podcasts, and please leave us a 5-star review.
Today, we'll be exploring an emerging topic in computing education and asking, what is machine learning? When and why should we be teaching it? We're going to be joined by some great guests to bring us their perspectives on this topic. But before we hear from them, I thought I'd get your perspective, James. How would you describe machine learning and AI, and why should educators be teaching it, in your opinion?
It's a really interesting, and as you say in your introduction there, emerging kind of topic. It's something that we've touched upon this in a previous episode of the podcast, that machine learning and AI kind of surrounds us in many ways. There are so many facets of our life which utilize machine learning technology that our young people having an awareness and understanding of what it is, how it works, and what its implications are, I think is really important. It's one of the next big kind of areas for them to come to get to grips with and to grasp. And I think to describe what it is, I think we see machine learning all over the place, but it's where we are sort of outsourcing some of our intelligence to the computer. We're training it, we're providing models, we are giving it lots of prior experience to then make decisions based upon. And it may not be making kind of informed decisions in the way that we make informed decisions, like weighing up the pros and cons necessarily. It may be spotting patterns and looking for sort of similarities between things. And those patterns may not be super apparent to us as human beings looking on the outside. The machine may be making judgments about patterns that we can't see. So I think it's really super fascinating as an area. We see it in things like we've mentioned our Netflix recommendations in the past. We're seeing machine learning having applications. Autonomous vehicles is quite often a frequently cited example. And I think within the curriculum, certainly within the English curriculum, there is definitely space for this. It's not something that's explicitly mentioned in the curriculum as, we must study machine learning, but there is definitely scope for looking at future developments and emerging technology within the aims of our curriculum. So I think it's definitely something that educators should be alive to and understanding and thinking about how and when they should be introducing it.
Yeah, I think what you're kind of describing is what I think about when I think about digital literacy. I hear this terminology used all the time, that we should all, whether we're adults or children, be digitally literate, right? So we should understand the technology that is around us. Like for me, that's not just I can move a mouse or push a button or write a Word document. It's, do I understand the technology that is ubiquitous around me? And you've cited some really good examples there, like Netflix you use there, but I would even talk about social media. We scroll through social media and social media recommends certain things for us to understand and content we might be interested in, right? But the more that happens, the more we create a silo to ourselves, and that has actually wider implications. And we've seen that with elections over the past few years in different countries. I think there's something about the large-scale collection of data that happens for all of us as we, data that's being tracked about our movements and what we do and what we eat, all of that. I think we should know a little bit more about what happens to that data. I think machine translation is something I've been really interested in over the past few years. We can use tools to help us translate words into different spoken languages. And that's really great because it helps connect us around the world. But sometimes the machine isn't, it hasn't been trained well enough, or perhaps isn't clever enough. I hate to use that phrase, but it doesn't ensure, where there are languages with different genders, that there is always, they don't accidentally always default into a male language, right? And masculine kind of verbs and so on. So there's something for me, about digital literacy, which means we should all, whether we are a teacher or not, we should all care about that, right?
Yeah, absolutely. And then for our educators in computing, I think it's then about how do we delve deeper so that those that do have that passion can really start to understand the nitty gritty and start to be the developers of machine learning and AI of the future.
Because I'm glad you kind of said that, because I was worried that maybe we were getting a bit too niche because you and I are colossal nerds. But now I feel kind of reassured that this is a good topic, and I'm certain that our guests are going to help us with this. It's pretty clear we're going to need some help in exploring these questions. So I think we should probably get them involved.
Let's do that.
Okay, so joining us is software developer, machine learning expert, and author of the Machine Learning for Kids Resources, a collection of project-based activities to support young learners in developing their understanding of machine learning, Dale Lane. Welcome, Dale. What is machine learning, and why should we all know more about it? Did we get it right?
Yeah, spot on. Machine learning is an alternative approach to getting a computer to do something. Instead of us giving the computer instructions that it should just follow step by step, with machine learning, we get computers to learn how to do a task by learning from data. We give it examples, it learns how to reproduce that. As for why it's important for children to learn about it, I think, like you said, it's about, you described it as digital literacy, but I think the more general point is it's about understanding how the world around them works. Because often when I talk to friends and family who are not in the tech sector, they sort of have this assumption that AI and machine learning is future sci-fi and something we'll do when we have spaceships and live on Mars. And it's to do with robots. And they don't associate things like Siri and Alexa as being AI. They don't think of when the smart assistants in our car as being AI. And often they're quite surprised when you point out that AI is here today and we all use these systems all the time. And, children are naturally curious and want to know how the world around them works. And I think explaining to them the basics of what machine learning is a really key part of that.
I think you've reminded me of something that one of my favourite speakers, Simon Peyton-Jones, said to me in an interview I was doing with him a little while ago, where he said that we teach our students all about the physical, the chemical, and the biological realms of nature. And okay, this is an artificial kind of construct, but it's still the world around them. And it's why would we not educate them about all facets of that? And as you say, machine learning isn't this futuristic technology. It's it's here, it's now, we're using it for better or worse. So we should understand it and its implications.
So what are the key principles and concepts in AI and machine learning that you think kids are curious about?
I guess the two sides to it are, what can the technology do? And I think because so often the explanation kids see about AI and machine learning is what they see in the media, which has a mixed history in accurately describing what the tech can do. So I think part of it is just that baseline idea of what is possible today and what isn't. And I think the other side that I found that children get really engaged in is that what I would think of as a debate about AI and ethics, about what should we be doing, what's appropriate, what is fair. Even at quite young ages, the students seem quite up for engaging in that debate about what they think is a reasonable use of AI, and not just use of AI, but use of their data. You mentioned before that so much data is being collected about everything we do, and what we buy, what we watch, what we listen to, who we talk to, and all of this is being used in machine learning systems. And I think the next step after helping them recognize what these systems can do and what they're being used for is getting them to start think critically about, well, what do they think about that? And because I think that's a debate that society needs to engage in. I think we've been quite slow to allowing tech companies to sort of do whatever they feel is cool and shiny. And there's a need for us to catch up as a society and have that debate about what we're comfortable with and what we think is appropriate. So starting at the education level, having that debate in the classroom, getting students to start thinking about these topics is a really good way of seeding that.
And what kind of conversations do you have with the learners in your experience when you do ask them to kind of debate the ethical or moral or the use cases for machine learning? What are the kind of ideas and challenges that they kind of perceive with its use?
There are lots of different aspects. So one example might be sort of bias. This idea that we sort of assume that a smart computer is going to give us the right answer, and a poorly coded, poor algorithms, a dumb AI will give us the wrong answer. But once students start to play with this stuff and start training their own models, and they start to see that the computer learns from the examples we give it, it picks up on patterns in the data that we choose to give it. And it's actually the point that you were mentioning earlier about translation systems, that the computers aren't smart enough to recognize gender defaults or genders in language. It's not that the algorithms aren't smart enough, it's that they're reflecting back to us the biases in our own society and our culture. We fed them with a load of documents that have these assumptions that doctors are male, that nurses are female. And then we're surprised when actually it's learned from us. It's spotted those patterns and it's reflecting them back to us. So I think it's actually those kinds of experiences are really great for students to actually start to question how we want these systems to behave. Because then you can get into debates about, well, should we be sort of skewing, influencing the answers the system gives to not just reflect the training we've given it, but actually if we want to start influencing it so that it behaves more the way we think it should do. So actually the gender in healthcare is a really nice example. And actually, the other examples I've seen are like CEOs. I've seen examples of systems where they assume a CEO is a white middle-aged guy in a suit. But if you just collect examples and give that, then that is what it will learn. So, like, what responsibility do people who are creating the systems have, not just for blindly collecting training data and then thinking that absolves them of any responsibility, but actually thinking about how these systems are going to be used and the outputs of these systems and what they have to do to make sure that the output reflects what it should.
So Dale has been talking a little bit there about how learners kind of interact with this and start to learn more about machine learning. And thankfully, we're joined by Nick Hughes, who is a teacher and computing consultant who's recently been teaching his learners about machine learning and AI. What age group of young people do you predominantly teach, and what was your motivation for introducing them to machine learning?
So I mainly teach Key Stage 2 children, so that's 7 to 11-year-olds. But I've only ever really done the machine learning with the top end of that, so probably year 5 and 6 children. Why did I start trying to do it? I think after seeing it demonstrated, I met Dale at a Raspberry Jam, I believe it was. I think you were demoing it at an event there. And I sort of was like quite amazed by what it could do. And I think some of the questions it started to open up, which is what we've just been talking about, to do with digital understanding and bias in data and all of these types of questions. It opened up loads of questions, and the children in our classrooms today do interact with AI all the time. As we've said, they've got these smart speakers, or they've got Siri, or they've got Alexas and all this sort of stuff. So the idea to try and starting to get children to understand how they work just seemed to be a really logical thing to start talking about. And a lot of kids often ask, like, how does that work? What is going on? The really inquisitive children will ask that. And it isn't as simple as, oh, it's programmed, because it isn't programmed quite in the same way. And so suddenly it opened up this new sort of area to talk about. And of course, I hadn't really heard a lot about machine learning before seeing Dale talk about his great resources. But from there, I've been sort of quite interested in it over the last few years. And I think it's a real important area to start exposing our children to as early as possible, because I think the moment they're starting asking questions about bias in media, and I think it's a big question we talk about from a digital literacy point of view all the time with our older children in primary, it's important to start thinking about that from the data sets we're starting to collect, and what does that mean? And all of those questions which we've already been talking about are all questions I've seen children ask to me about how does this work, and how does this work? And Google Photos is a great one. That's the thing that always quite fascinated me. I think that's the example that I don't think anyone mentioned, that of course Google Photos is based on machine learning, and the fact that how does it know that what the pictures are? Someone told it. And that's fascinating little experiment just to show, let's just type this in and look at all the photos it's picked up. So I've never tagged it Minecraft, but it shows me all the Minecraft pictures in my library straight away, because it just knows. And it's quite fascinating for kids to see that.
It's when it starts naming people in your phone's library. It's like, oh, that's your mum. And I'm like, what? And I think it named one of my siblings by a nickname. Like, I was like, how did you, what? I don't know where that came from. No, I think that's fascinating. And I think, some people might be listening to this and thinking that's quite brave to kind of try that experience with such young learners. I'd be interested in your reflections upon that experience. Like, were there aspects that they really took to? Were there aspects that they found challenging and were maybe a bit too soon for them? Like, what's your kind of reflection on that experience?
Sometimes the programming took second stage compared to just looking at making the data set. So there's some really nice examples on there. One of the examples which I've used quite a few times is making a machine that identifies the meaning of text, like is it nasty or nice. So that's the really simple idea. But it was creating the data set for that I think was the most interesting part of the children, to work out that, you have to give it loads of examples, and then from that example set, you have to train the machine, and then it might work, it might not work. And I think the idea of you inadvertently build bias into your data set accidentally, especially when the kids were generating their data set themselves, that was just an interesting conversation to have. So the programming side of it probably less so, because I know we're talking about it's not programming. There's still an element of you've got to start within the tools that with it on the website, you're structuring it using Scratch, or a bake of Scratch, isn't it, with the machine learning back end or built in there. But you've got to structure sort of the algorithm, I suppose, that it's following, but then of course it's pulling in the data set. So yeah, it was that was the side that I think was really useful. The kids were really getting the idea of what the data set is doing. Things that we're struggling with, I think, sometimes it's those wider questions, some of the ethics side. I think depending on their age, that's an interesting conversation. We did talk about the ethics of cars and how does a car know who to kill, which is a horrible thing to talk about, but that was a question that came up. It was like, well, how does it, and it's a really odd one to do, but that's quite a struggle to work through, because you go, and the kids had very interesting views on which ones it should be, which is like, okay, whatever. But that's the sort of thing of like how to keep things safe and what those things are. And there's a tool to do that, isn't there? There's a training tool for that I've seen online, which we did look at and explore a little bit, because the kids were sort of interested in it. But it's that real high level ethics, I think, is difficult for some children.
Not who to kill, who to save.
Yeah, who to save? Yes. Yes. Yeah. Well, yeah. It's true. Actually, it's one way or the other, isn't it? Yeah. The computer has to decide who to save. Yeah, that's accurate. But yeah, so yeah, it is that side.
Yeah, and if people remember back to episode 2 of this podcast, we actually spent a lot of time talking about the trolley problem and about ethics and how to have classroom discussions around ethics, probably with much older children. So it's really interesting to hear your view on kind of how that lands with younger children. But we've spent a lot of time talking about machine learning for kids, the tool. So perhaps, Dale, you could explain to us, what is machine learning for kids and how can educators use it?
So there's a few different elements to it. On the one hand, it is an online web-based way of training a variety of different types of machine learning models with an interface that I've tried to make as simple and child-friendly as possible. So children can prepare data and anything they can think of, it's either collecting sound recordings or pictures or sets of numbers or words or whatever it is, and then use that to train their own custom private machine learning model to do whatever it is that they've thought of. The second element is, as Nick was sort of mentioning, integration with educational coding environments. So Scratch was the first one I did and the one that's used the most. And there was a couple of reasons for that. Partly it was so that students could use their machine learning model in an environment they're already familiar and comfortable with. But also I think it tells a real story that, similar to what Nick was saying, that machine learning isn't replacing coding. Like, the fact that machine learning is on the rise, or the use of it is on the rise, does not mean we don't need to learn how to code. It's just another tool in our toolbox. It complements coding. It means we can do more interesting, powerful things with coding. It's not we use it instead of coding. So I think having it in Scratch as opposed to something new and different helped me tell that sort of part of the story. And finally, it's a set of worksheets to help inspire coding groups and classes of what is possible. And as many of the worksheets as possible are based on real world uses of AI. So the idea is that students can follow some step-by-step instructions to make a simplified version of some real world AI application.
I actually used one of the resources on there this week. I was playing with noughts and crosses or tic-tac-toe on machine learning for kids. I actually used Python to do it. And I think what is really interesting, and an aspect we haven't talked about, is training an AI to ultimately beat you. What I learned very quickly was the noughts and crosses AI was very, very quick to work out after playing about 10 games, was very quick to start beating me, like pretty much almost immediately. And that's always super interesting, I think, for young people. Do they respond to that kind of way in your experience, Nick?
No, it's interesting, actually. I use a lot of gaming within my teaching of programming. I think that's a method or a theme that I use in quite a lot of it. But actually, for machine learning, it isn't. I've spent most of the stuff I've worked with kids is things along the lines of a smart speaker, or so responding to something. So either making it do something, or responding to, like, if you say something, it knows if you're being nice or nasty. I've sort of focused on those types of examples. I know there are examples on Dale's site, which I've always looked at, but I've never felt the need to go quite as far as that. And maybe that's because when you start introducing gaming, there's suddenly a lot more complexity to the program. Suddenly you're introducing selection, and you're introducing variables and things like that. And so for some children, that's enough complexity without also adding on that machine learning level as well, and that new data set. So it's probably something that it sort of sits above, but also sits below that in terms of the complexity of how you might want to try and teach the children. I think it all depends on your cohort of kids, to be fair. If you've got some really keen ones, I'm sure it's a great thing to do to extend stuff, because, of course, there's plenty of games that we make. You could easily get them to get the machine learning model to beat you at it. So, for example, I've made plenty of Space Invader or Pac-Man type games over the years, which, of course, it's ideally suited to do that. I've seen some examples of that. But yeah, I've never pushed quite as far as that at primary into the gaming side.
I think one of the great things that it does is it shows you the decision tree. I think what I really liked about doing this was training the model, and then being able to go back to machine learning for kids and see the decision tree that had been built by playing the game over and over, and that was really interesting. But I also, in Scratch, a game I created was rock, paper, scissors. I think using Google Teachable Machine very quickly, using that tool and then embedding that into Scratch is another really great way for younger children to start thinking about that. How many images do you need, and what kind of images will represent the different gestures, and programming those, I think, is a really nice way into. James?
I think that just to Nick's point about, like, maybe with the early students maybe not needing to go or wanting to go into the sort of slightly more advanced programming things, I think one of the things that plays really nicely at primary, in my opinion, is that a lot of what machine learning is doing is about categorization. You know, we're taking things and we're categorizing them as naughty, nice, or, you know, cat and dog. And I think that that's something that in their formative years of education, pupils spend a lot of time kind of categorizing and cataloging and identifying things. And so that experience is almost sort of second nature to them. So it plays really well, I think, to that. And then your mention, Carrie Anne, of the decision tree reminds me of a really nice unplugged activity, and I'll have to find out who did it. I think it might have been Paul Curzon, and I'll find a link to it, where you're teaching a sort of machine to play a game, and you're using little sweets to reinforce. You've got little sweetie cups, and every time it makes the right decision, you top up that cup. So that's and so you can kind of reinforce the most appropriate decision at that moment. And that's a really nice way of getting it across away from the computer and away from the programming. It's a really interesting reflection, I think, when you've got that sort of sandbox toolkit environment, and you can just make observations and spot things and learn things that you didn't think you were going to, or that you've got those nice kind of happenstance kind of moments. Carry on.
As ever, play is useful in teaching. Who knew? Who knew we should let young people play and tinker?
Absolutely. So I've got a question for both of you, actually. So we've talked about, and we've mentioned quite a few different activities, but if we were to think about the sort of suite of activities that are there, and it could be from Dale's set of resources, or it could be from the wider kind of resources that are available, what's your favourite activity to really kind of engage learners or demonstrate the power of machine learning or get them discussing something? What would be your recommendation?
You mentioned the rock, paper, scissors project, and it's only happened once, and it was a total fluke, but I've told the story a few times because I really like it. If for people who haven't seen the rock, paper, scissors project, the idea is that you use the webcam, you hold your hand up to the webcam to make different shapes. The computer learns what a rock looks like, scissors and paper, and then it plays against you. And I think it was like the second or third time I'd run this with a class, and there was a student who did a really good job of collecting examples of their hand doing rock and scissors. And then when they were taking pictures of their hands for paper, it so happened that one of their classmates had come and stood next to them and was sort of just about in shot and was in the picture while they were taking their photos. And then they went back to finish their work. And what they hadn't spotted was they trained the machine learning model to think that a hand meant rock or scissors, and a hand and a person meant paper. And they hadn't noticed they'd done that. And it was only when they'd made their Scratch program and they'd started playing it, and it was getting rock and scissors, and then the teacher or I would come and stand next to them, like, over their shoulder, see how they're getting on, and it kept saying paper no matter what they did with their hand. And they thought it was broken. They thought there was a bug. They thought there was something wrong with their code. And then we went back to their examples and said, well, what do all of these have in common? What have you taught the computer? Like, the computer didn't know the hand was the important bit. The computer learned what you taught it, and you taught it that a person meant paper. And what I love about, it's been ages since I've been in a classroom because obviously COVID. But what I used to love most about the projects was giving them time to explore and experiment and stumble onto those kinds of lessons that I never even planned, that they just sort of accidentally, through getting that chance to play in a friendly sandbox, would start to learn things about the technology.
And Dale, is this like picking between your children? Which of your activities do you think is your favourite?
So I would probably pick the one where you turn on the devices. Is that still a smart speaker one? Yeah, that, the one where you can turn on lights and turn on fans. I think I'd pick that just because it's really within kids' experiences. They know what they're trying to do there. I think I would definitely pick that one. That would be my sort of first port of call.
There's a one from Mozilla called Survival of the Best Fit, it came out of when there was news stories about bias in hiring practices, where a company had automated sifting through CVs and picking who they wanted to recruit, and that ended up reflecting bias of their previous hiring practices, and it was horrendous. And what Mozilla have done is a really nice project where you can go online and you play this game where basically you decide whether to accept or reject a candidate, and you're training a model, and then it shows you the biases in what you've trained, and actually you end up, without realizing, training a model that is biased. And I like that, because there's too easy to fall into this trap of thinking that training a biased AI means you've been negligent or malicious or you're a bad person, and actually realizing that it happens accidentally, that people don't mean it to happen. And the game forces you to do it by putting you under time pressure. It makes you make decisions quickly. And then it shows you that you've made this horribly biased system that is rejecting people for no good reason. And I've had really good discussions with classes after sort of playing through that game and talking about that this isn't a totally abstract idea. This really happened. And come back to what I was saying earlier about, it gives you a chance to have that discussion about the responsibility that people who are making stuff with this technology has. The projects that enable that ethical debate, the discussion about how things work in society, those are the ones I really enjoy. Because I love the lessons where I've had the time to, once the project is finished, for us to get around and discuss it and see what their opinions are. Like, that is the most exciting, interesting part of the lesson. The making bit is just what enabled that discussion to happen.
And hopefully they can connect it to other real world scenarios, right? There's something about making that concrete, that learning, and connecting it to the world around them, bringing them back to that starting point, I think is really valuable.
I love that. I think that reflection is always, when I was in the classroom, one of my favourite kind of things is where you do an activity and then actually if you carve out some space to discuss and reflect and talk about whether it's like ethical issues or how you approached a problem or whatever. I think that time to engage, you really kind of get a chance to observe what the students really understand and feel about that topic.
It sounds similar to one, which is playing a different resource from code.org called Oceans, which I quite like, and that feels really primary. And I think it's a really nice tool to really showcase the real basics of it, the real starter point. So that's an activity that I probably would use fairly early on with children as well.
It's about picking a topic that kids care about. Like in the grown-up world, the default go-to project for training a machine learning model is something like a spam filter. But that doesn't work in a primary school because kids don't get enough email to know or care what spam is. So I think you're right that, would a young primary school child know what a CV is, know what applying for a job feels like, would they feel invested and really care about how job applicants are treated? So I think, and maybe oceans is a really nice example because kids do care about sea life and I think maybe picking themes that are relevant is the important bit, and maybe that is more of a secondary school sort of topic.
So it doesn't seem like age is the barrier to teaching this or even understanding it. The barrier is more around the context, making sure the context is age appropriate. So having some that are more towards the younger age group, kind of 5 to sort of 7, there's probably a context there that works around marine life. There's probably one that's kind of good for 7 to 11-year-olds, maybe around smart speakers and connecting it to technology. And then probably when you get to 11 to 14-year-olds, you're probably more moving towards some of those game-based activities that we talked about.
I do the same projects for different ages and they get different things out of it, like the one Nick mentioned around sentiment analysis. If I do that with a young primary school class, it's just about bringing to their attention, computers can learn to recognize tone and sentiment, and computers can recognize positive, happy text versus negative text. But I'll do the same project with a secondary school class, and we will try to push the boundaries, show what, computers are really bad at spotting sarcasm or negation, or, actually start, because you can have that debate with them about, well, hang on a minute, if the message is computers can recognize insults, then why is trolling on social media still a problem? Why hasn't it been stamped out? Well, actually, it's really hard to recognize because of these things. And then you get the students to experiment and push the boundaries and finds out, well, this sort of stuff a computer can do, this sort of stuff a computer's not very good at. It's the same project, but you get that opportunity to dig a little deeper with some of the older students.
I think to sort of go back to what you said a minute ago, Carrie Anne, about the version, and what James said as well about younger kids understand sorting things really well. So I think a context around what is a cat and a dog, what is a cow and a sheep, it's a really simple thing that they can do, but actually that's a nice context for them. And it feels quite funny when why are you identifying this cow as a sheep or a dog? And it's then starting to have that conversation. But it looks a bit like it because of the colour. And suddenly you're having the same conversation you had with the child with standing by, the hand and the person is a flat piece of paper. You're having that same conversation with them again, because they're starting to understand a little bit more at their level anyway, that it's not as simple as we think it is. We look at it and instantly know what it is, but a computer does not have our reasoning and capabilities, does it? Not quite in the same way. So therefore our reasoning, when we look at a picture and go, I know what that is straight away, but a computer, it's not as simple as that. So it sort of highlights its limitations. Even at a young age you can do it. So I think that's why it's really important just to talk about machine learning, because it's around us everywhere. I don't see it going away tomorrow at any point, is it? I don't think. And so therefore it's in the same way we're talking about programming, because it's around us all the time. Machine learning is that next little bit, and AI is that next little bit, the next stage of programming. So we need to have an understanding of that in just the same way we need to have an understanding of how our banking works versus banking's about how traffic lights work. That's a much more a basic example, isn't it? In the same way, we need to know how light bulbs work. It's a part of the world around us, as you said. It's a part of the real world, the physical world around us, but it's that digital world as well that we're all a part of. So it's really important to have those conversations and expose our kids to them as early as we can in the right context.
And students, because I do a lot of those kinds of sorting projects, and they're often surprised by what the computer can and can't do, or things that, well, why can't the computer work that out? So one I did was on recognizing apples and tomatoes, pictures of apples and tomatoes. And you make sure that we train it with photos of green apples and red tomatoes. And then you show it a red apple and it thinks it's a tomato. And like you were saying, Nick, we think it's so obvious. Well, of course that's a tomato. Of course that's an apple. Why can't this really smart, clever technology tell what an apple is? And that's because you've told it that red things are always tomatoes. So that's what it's learned from your training. So I really like examples where you get kids to realize that, yes, this technology is everywhere, and yes, it's really powerful, but it has limitations, and it's limited and affected by what we teach it.
something I've done years ago was fiddling around with some machine learning model tool and accidentally taught it left and right incorrectly, because I don't know my left from my right. So I accidentally did it the wrong way. And it was doing it wrong. I was like, why is it doing it wrong? And then realised, I've just taught it the wrong data set. So, of course, the idea of bias is if you teach it incorrectly, incorrect bit of information, I've taught left and right the wrong way around. And that sort of really just highlighted it for me years and years ago when I've used something. I can't really remember the tool I was using to do it. But it's just that thing of, it's those fun discoveries, isn't it, that the children get while completing the projects, which is probably almost more beneficial than the sort of the programming side of it, or even the model building side. Because I don't think, in terms of the stuff we do at primary, definitely, I don't think any of the programming elements are that complicated. And I think your website is really good at supporting and scaffolding that side of it. So I always think the machine learning model is the more interesting bit of it, and building that side of it, definitely at the primary age we're talking about.
Thinking about training and so on. One of the things we do with this to generate our transcript for every episode is we run our audio through a machine learning transcription service. And I still haven't got it to recognise Carrie Anne's name. It constantly refers to her as Carrie on Philbin, which I'm working on correcting, but we haven't got there yet.
This idea of when to introduce young people to machine learning and AI is really interesting. We surveyed our listeners via social media asking, when and how do you introduce machine learning concepts with your learners? Results have been quite mixed, but mostly they indicate that you prefer to introduce these concepts to ages 11 to 14 and 14 to 18, which I think is really interesting considering our two guests both talked about much younger age groups.
That is really interesting. I think it maybe there's room for these concepts to be kind of taught a little bit further down the screen. Is certainly, I think, the view that our guests had. Just a couple of comments that we had from our audience as well. So Stuart Cording talks about having taught machine learning with a year of 7+ age groups and 11+ at their local school. They ran a program on the PC which used their camera to learn traffic light colours with a neural network, and they trained their camera and learned how cameras can see, in inverted commas. And we also heard from John Witts, who teaches machine learning and AI to his year 9 students, that's age 13 to 14. And they cover it in a short unit which looks at AI, the future of work and ethics, and things like driverless cars and other technologies. And they think in that context, it might be harder for younger students to access. But he's looked at the machine learning for kids resources and thinks that they would be a great resource for younger learners.
Well, my thanks to Dale Lane and Nick Hughes for sharing their expertise with us today. You can read both their articles and activities in issue 12 of Hello World magazine. If you have a question for us or a comment about our discussion today, then you can email via podcast@helloworld.cc, or you can tweet us at helloworld_edu. So, James, what did we learn?
Well, I personally learned, I think that there's this theory that machine learning and AI, it's not beyond the reach of our youngest learners. And there are interesting and engaging ways for them to begin to understand these concepts. And whilst a lot of resources are becoming available, I think there's still room for some of those tools and ways that the learners access this content to kind of develop a little bit further. But it's really interesting. And how about you, Carrie Anne?
Well, I mean, I've learned what we always learn, James, which is that machines can't understand my name. All transcription services always call it Carry On Philbin.
And indeed, Carry On Philbin.